Good afternoon. I should probably start by describing what it is I do, and that's basically I design decision support systems and their applications for landscape or environmental analysis and planning. That's such a mouthful, it doesn't fit on a business card, so I'm very happy to hear I can probably just call myself a GeoDesigner now. And I think I went by a slide, sorry. Okay, first of all, I've been in charge of development of a system for a number of years. It's called EMDS, which stands for Ecosystem Management Decision Support. And I'm not really going to go into much of a description of the system, just give you a very general idea about it. Really the focus of what I'm going to be talking about is kind of the experiences with developing it as they, I think, hopefully relate to GeoDesign. It's a general application framework for designing and implementing knowledge-based decision support for environmental analysis and planning. Again, a mouthful. And it's designed to support any geographic scale. It integrates GIS, of course, but it also includes knowledge-based reasoning technologies and decision modeling technologies to provide decision support with the idea of supporting, as far as possible, the adaptive management process. Just a little bit more background, and then I'll get on to the main points. It's implemented as an ArcGIS ArcMap extension, and for the GIS averse, an ArcEngine standalone. It integrates a logic engine from rules of thumb software to perform the landscape environmental evaluations, and a decision engine from InfoHarvest to support strategic planning. So that's as much as I'll say. Later on at the 5 o'clock session, I will be out there with a computer if anybody would like to actually see what this thing actually does. But these are some comments I thought were pertinent to the discussion today. Some of the experiences are, and lessons learned, if you will, has been real value in a very generic framework design approach to delivering this technology. It not only supports large, complex, abstract problems, and I was very happy to hear somebody mention abductive inference earlier. We use logic engines particularly because they're very well suited to handling abductive inference problems. And in particular, these kinds of models accommodate a very diverse array of topics. They're only constrained by, can you describe in logical terms what it is you're trying to evaluate? Some of the more important lessons learned along the way have been the importance of transparency. Decision support is more than providing just pretty maps. The things that have been critical to the success of this technology, at least to date, is that it provides a rational, repeatable, and fully documentable process that is necessary to support planning in an effective way. And perhaps most importantly, transparency. These kinds of technologies offer a way to provide very intuitive explanations of model results. And the acid test here is that senior level managers in the federal agencies that I work with can stand in front of Congress and give them an intelligent explanation of what the models do that they're using. That's, I think, has been a significant point. The other thing has been, I think one thing that was learned along the way, mostly because the system has evolved over time, was as we put it into practice initially, it was designed to do landscape evaluations. And we saw people trying to use it for purposes for which it was never intended. They were trying to both interpret the landscape condition and prioritize things at the same time, and it was a big muddled mess. One of the things we figured out in one of these V8 moments, if you will, was that if we added an explicit decision component to complement the logic modeling component, all of a sudden we had very much simpler problems, and it was easier for people to conceptualize and implement models with this very simple addition. The other things that have been significant, I think, in terms of the success of these kinds of technologies is the ability to provide reasoning in the presence of very incomplete information, particularly in the context of environmental or landscape analysis, where missing data is a perennial and persistent problem. This is, I think, a very valuable feature to have built into any kind of decision support system. And finally, it's a minor point, I guess, but it's been designed from the beginning with the idea of supporting multiple interdependent spatial scales of analysis. Some things I just wanted to conclude with. This is not a matter of boasting, but just to put it in perspective. It's been around since 1997 as a production release. It was originally developed, the first 3 versions, by Esri under contract with the government. We're at version 4.1 now. And what I would, rather than give you an extensive explanation of all the kinds of applications, I'd refer you to the Wikipedia site that's listed up here. There you'll find a good breakdown of all of the applications that give you some idea of the broad array of topics for which this kind of technology has been applied, any number of different spatial scales and all over the world. It's a good indication of what these sort of design criteria have sort of brought along the way. And then lastly, I just refer you to the home page, which is EMDS is now under the stewardship of the Reynolds Institute, which I've been extremely happy about. It doesn't sit inside the government anymore, but it's a private nonprofit. I'll stop with that. Thanks.